Okay, so today's short video is a fan favorite for period one. We're going to go through what has affectionately started to be called the Sarah box. And so for period 910, it's because Sarah Pathy just loves this box of information. And so today's important idea is going to be squeeze theorem. We've been working on it all week. Let me take a minute and write that down. There's not too much information for this beyond what you already know, but I think it's always good to have, something to reflect back on. So we're going to look at this two ways, graphically and algebraically, because they're the two ways you're really going to see these problems in the future. Okay, so graphically, you're going to create your own axis. Sorry, I was trying to make sure these lines are straight while doing that. And then you can pick any three functions you like. So we've seen a couple. I'm just going to draw like a parabola. Maybe we'll get a little x to the third kind of hanging out in there. So let me have that. You can see where we're going to squeeze the point now, right? And we're going to call this f of x. This first one, f of x. We need one more function that we're going to squeeze. So we'll just, I don't know, we'll wiggle that around. And who knows what that is, but we're going to call that one g of x. And the final one we're going to call h of x. Oof, what the heck happened there? Okay, a little. That was still giant. Sorry, guys. I don't know how that happens. H of x. And so then what we see is that g of x is squeezed between our upper function f of x and our lower function h of x. And so the limit as we approach this some constant c is going to be the same for all three functions. And so when we talk about that algebraically, we have h of x is less than or equal to g of x is less than or equal to f of x. And so that what that will say is the limit as x approaches some value c of h of x is equal to the limit as x approaches some value c of f of x. Therefore, by squeeze theorem, the limit as x approaches c of g of x also equals that limit. Okay, and so then for your classwork over, I believe today, I want you to complete the check your understanding. I think number one, you need to graph. I would use Desmos, it's always easier. Make sure you're looking at the interval they give you. I also think you should graph the second one. I would graph sine and cosine again on the interval that you're given. The third one, I think you can graph if you'd like, but just certainly look at explaining why the theorem can't be used here. For number four, it's pretty straightforward. The table gives an excellent view of the points. Do not try to graph number four. So the graph is a suggestion for the first three, but for number four, I would just use the table. Okay, enjoy, have fun, and I will talk to you soon.